the VMs and now containers, and now the future is AI. So and we have like a couple of talks around AI here. So without further delay, I would like to kind of kick off this large-scale production engineering meetup 48th edition, and I would like to welcome Rashid and Ayush from CRED to present the achieving data security at massive scale on cloud-native organizations.
security at scale for cloud native environments, but it's not specifically restricted to cloud native environments. It could be any different kind of environment, be it hybrid or be it on a DC, the techniques and the principles are going to remain the same. So before we even start, I want to do a small exercise together with everybody sitting here. To get a sense of what we're going to talk about, I wanted to do this simple exercise with all of you. On the screen, you see a QR code, and there's a website. I would want all of you to go to this website or scan this QR code and enter your personal email address that you most commonly use. Don't worry, it's completely safe to do so. Just do this and click on submit. Let's do this together and see what do we get out of it. Enter your personal email address, do not enter your corporate email address, the one you most commonly use. If you have already done this, you're going to see something similar to this. So what just happened is whatever websites or applications you signed up with, they might have faced a data breach somewhere during their timeline. And the way it works is attackers dump the databases they get from these organizations and put them on sale, either on the dark web on some hacker forum. And this website has a record of all the public known data breaches. And that's why it's able to tell that data associated with your email address is associated in a public domain. And let me tell you, this is just the tip of the iceberg. The data collected by this website is very minimal compared to what is actually out there. So I want to do this exercise with all of you, just to give you a sense that even if you do not realize that how important data security and privacy is for you, but all of us are living in a digital world where we can't escape from it. And that is why, as an organization, it is really crucial for all of us to understand the importance of this. I'll move ahead. I'm Rashid Firoz. I'm heading infrastructure security at CRED. I've been here since last 4 years. I'm joined with my colleague Ayush Priya, who would be taking the second half of the session. He's working as a cloud and data security engineer at CRED. Moving ahead, I want to talk a bit about why do we even want to talk about, or why do we want to do data security and privacy. Can anybody here talk about what is the basic difference between data security and data privacy? These two terms are very commonly used interchangeably by many people. Uh, Anybody wants to talk about it? What's the basic difference? Whatever comes to your mind. Okay, so the very basic difference between data security and data privacy is data security talks about how you can secure your data, the confidentiality of the data, how you put different access controls. It deals from more from a technology lens, how you put different access controls, authorization, etc., to basically lock down the data and prevent any kind of data breaches. Data privacy comes into the picture. Let's say I am Cred and you as a user are giving some data out to me. That's where the data privacy comes in, as what do you want to be done with your data, right? It could be Cred, it could be any e-commerce company or any other company. So what do you want to be done with your data after you have already given the data to an organization? That's where data privacy comes in. So data privacy laws governs everything around it. And to be specific, I would want to talk more about data security over here, given it has more of a technological angle. Data privacy has more of a process angle. But definitely we can discuss on both if needed. So why do we even do data security? There are very obvious reasons. Just you saw now in your phone, if organizations are not careful about this, what could go wrong? Starting from financial loss, reputational harm, customer trust, brand erosion, etc. And then we are a fintech organization, and we are operating in a heavily regulated space. We have more than 30, 40 audits per year. And apart from this, we also wanted to ensure that we held the highest standards when it comes to securing our Cred members' data. And this is why we started our data security journey at Cred way back, a few years back. And I'm going to talk about what we have done and where we have reached now. Before going to the next slide, how many of you are aware about this privacy bill, privacy act, which just got passed by the government of India in this session? Okay, so India has a data privacy law now. It wasn't there before. It is somewhere, you can draw parallels to GDPR, which is operating in Europe. It is currently, it is called as DPDPA. This bill was drafted in 2018, and it took 5 years for the government to pass this as a law. And we have seen multiple iterations of it. As I said, if you're aware of GDPR, you would be able to draw some parallels out of it. So there are multiple technicalities in it, which I'm not going to deep dive. What is interesting here is something called as data fiduciary. So any company or any organization which is collecting any personal or sensitive data from their users will be categorized as a data fiduciary. And you're obliged to follow all the obligations that the data that the government of India has mandated us to do. So every org, be it an e-commerce app, be it fintech app, be it a ride-hailing app, be it a food delivery app, if you are collecting any personal data of your users, then you have to oblige by DPDPA within coming months or maybe a year. So if you have not started to think about this, then maybe it's the right time to start about this, thinking about this, given we don't have a choice. And it was a big win for all the data privacy enthus, given we did not have a proper law so far. So these are some of the uh, obligations that a data fiduciary or any company who is collecting data from the users are obligated to. So we're not going to talk about DPDPA today. We're going to talk specifically about data security. And there are certain common touch points between the law that just passed by the government and what we have done within CRED. So if you see, data principles is basically nothing but any user or consumer who is on that website or on that app who is passing the data on to you. Basically, you are obligated to implement technical and organizational measures to safeguard their personal data. If you fail to do so, the government has come up with a very strict penalty this time. The penalty is up to 250 crores, ranges from 10 crore to 250 crores. The details are would be on the website. You can go ahead and read it. So they are pretty serious about data security and privacy laws this time. Moving ahead, so we started our journey way before this DPDPA came to us a few years back when CRED started. And the only reason was we wanted to ensure that we are holding our customers' data, our members' data in the highest regard. And the moment we started, we realized not a lot of companies have tried to solve this problem. There's not a lot of information on the internet available. We did some research. Enterprises had done it really well. To name a few, for example, Microsoft, Google, etc. But when it comes to startups, it's a difficult problem to solve. Given the scale of the data we operate in, the org complexity. For example, if you talk about a data lineage, when a customer enters any data onto your app, what happens with that data? The data flows through the servers to a database, relational database most probably, and from there it flows to a data warehouse. And from data warehouse, I'm talking about a very simplistic architecture. From the data warehouse, BI tools or business analysts might want to run some query to get some business intelligence out of that data. Right? This is a very simplistic architecture. There could be a lot of other moving components based on the complexity of the org. Now the same data gets copied to multiple locations. It could be S3 buckets, it could be file shares, it could be logs, etc. So the scale of the problem is huge. And when we talk about data security, we have to think about holistically as within my org, what are the different touch points or places from where my sensitive data could get leaked. I'll start with, for example, a cloud data stores. Right? If you're operating in a DC or a hybrid environment, it could be different for you, but essentially it could be in relation database. PI data can be stored in NoSQL DBs, non-relational database. It could be a flat file storage such as S3 or a data warehouse. Some of that data might flow into some of the communication mediums that we use. We have laptops, we have logs, we have a lot of internet platforms and tools. So if you look at the complete set of data touch points, it is very difficult to implement one solution for all of them. So we can't just go ahead with solutioning that, okay, I'm going to solve for each one of them. So what you can do is you can define a scope. For example, you can figure out where your most essential data lies. For example, for us, it's cloud data stores. So what I'm going to do about it. And to further give a sense of the complexity of the problem, to further give a sense of the complexity of the problem, what I'm talking about is petabytes of data stored in different data stores which have different access patterns, different usages, and then there could be hundreds of code repositories, databases, vendors, some of which you might be sharing some amount of data with. There could be millions of users, LOBs, etc. So this was to give you a sense of the complexity of the problem that we faced when we started on this journey. And slowly we came onto few realizations. And that's what I'm going to talk about. So we have uh, documented a 7-step process to do that. I'm going to talk about each one of them. So uh, the first pointer would be here is, given the data touch points is huge, you need to define your scope if you're starting out. So the strategy might differ based on whether you're a startup, whether you're an enterprise, right? The scale you're operating in, right? Or complexity. But you can follow this as a generic guidelines when trying to implement data security. So the first thing is we need to identify all the different kind of data touch points where your customer data or sensitive data flows through. Right? Once you have defined your scope, then you need to understand your environment, because each organization behaves like a different organism, right? And each one's could be different. So in security, we call something, we use this term called threat model. It is basically something called as risk assessment. You basically identify uh, what are the security controls around different data stores and what are the gaps around it. For example, if there's a relational database, MySQL, how do people access it? Whether encryption is enabled or not, whether login monitoring is there or not, how is backup being done over there, right? Same for every other data stores that you have. And once you have got a deep understanding of how the engineers or the developers or business analysts access your data, it would be easier for you to solutionize or define a solution for them. You can't just blindly go ahead, buy a commercial solution or implement a open source solution unless and until you understand the complexities of your environment and what solution will fit in the best. Uh, Once you have understood your environment, your data access patterns, who accesses the data from where, what is the use case, what are the current gaps, uh, the next problem is, given we're talking about petabytes of data, we do not know where my sensitive data is. This is the biggest problem, right? It could be lying in some S3 bucket among hundreds of S3 buckets. It could be in some random obscure NoSQL DB. It could be within a streaming platform, uh, anywhere, right? So we need to ensure we set up automated data discovery and classification process across all the data stores, which basically automatically scans all your data constantly and tags where is my personal sensitive information, right? It could be the customer's name, email address, credit card data, financial data, whatever you classify as sensitive. Uh, and this is one of the most crucial steps in order to achieve data security in any org. You need to understand where is your sensitive data before putting in any kind of control. You cannot put blanket access control. Okay, from tomorrow nobody's going to access any database. I'm going to block everybody. You're going to essentially block business. So you have to be very selective and precise about what kind of access control and data reduction you want to do. Once you are, have done with this, you can, of course, strengthen your access control via this risk assessment exercise that we talked about. As if there is this particular data warehouse, who all is accessing it? What are the BI tools in use? Is my PII, personal identifiable information data, is flowing into my data warehouse? Can people query and download it and see it? Right? So we need to set up proper access control mechanisms over there. It could be open source solution, it could be a commercial solution, or it could be a solution given by the provider itself, OEM solution itself. Uh, though the act we talked about, DPDPA, does not specifically talk about sensitive data masking and reduction, right? It majorly focuses on the data privacy angle, but we wanted to go one step ahead and do not let ourselves be restricted to one particular compliance angle. So we did sensitive data masking and reduction. ICE is going to talk about how we achieved that. So our objective was, one of the objective was to provide PI-free data to analytics, so that analytics team does not need to see any sensitive information of our customers. And even an engineer who does not have the requirement to do so should not be able to basically see any sensitive data. So we wanted to find a sweet spot between not blocking business and also enabling security at the same time. Uh, Going ahead, you can implement data loss prevention wherever applicable. Let me tell you, this DLP agent installed on your endpoint or laptop is not a silver bullet. It's not alone going to solve for data security in any org. There are multiple steps to do so. The better is to control the access at the source rather than putting controls on the laptop and relying on it. And as a last step, what we did is we enabled federated data governance. We rolled out policies and standards as this is how you should access the data, this is what you're allowed to do, this is what you're not allowed to do. And one single team cannot be responsible for massive amounts of data held in any environment. So multiple teams needs to come up, take ownership, and follow the process and standards and procedures that you have set up. And this is what federated data governance enables us to do so. I would want to hand over to Ayush, who's going to talk about more about the pointers we discussed now. Thank you.
Hey folks, thanks Rashid. I'll be talking in detail about like the steps that Rashid just mentioned, right? So to begin with preliminary steps, right? One of the first few steps that we had to take to kick off the charter itself was to figure out how are our peers, how are our industry peers actually trying to solve for the same problem, right? How are they trying to achieve data security at their orgs? And along with that, what are the tools available, be it commercial or open source, to figure out because writing everything from scratch might not be the best idea to go forward with it, right? So these two things, and to our surprise, we figured out, as Rashid also rightfully mentioned, like most of the startups have not tried to solve this holistically. They might have taken a chunk of the problem and tried to solve for it, but not the problem as a whole. And the next bit was to do an extensive threat modeling, right? Threat modeling essentially is an exercise that you want to do for your infrastructure data. So you can do it pretty much for anything, where you try to identify gaps in terms of security controls and the scope that you have defined, right? So we did it for all of our data stores that we primarily use, be it an RDS instance, be it a data warehouse like Databricks, be it object storage, right, S3. So all of them, essentially, to figure out the current status that we are at, right? What are the current controls that we have implemented? Are they adequate enough or not, right? So we know where we stand, and we also know where we are supposed to go, so we can track progress in the meantime as well. The first leg of the problem to solve for is to figure out what data stores you want to like focus on, right? So once we identified that, right, for us it primarily was RDS, traditional RDBMS databases, Databricks and S3, right? So one of the first exercises that we had to do was data discovery and classification, which basically means you scan your databases to figure out if they contain sensitive information. Again, scoping is another thing that you have to do as part of the planning itself, right? So our scope, when we say sensitive data, we meant PCI and PII data, right? Sensitive data could also be credentials, passwords, SSH keys, right? But for the sake of the context that we defined here, it's PCI and PII data. So that's what we wanted to do. And to begin with, we wanted to build a custom solution as well, to just take a look at it if we can build this solution from scratch. And for the same, we tried out AWS Glue, AWS native tools that were available, as well as some open source tools, be it PII Catcher, Apache Ranger. And all of them have some caveats, pros and cons essentially, right? So for example, AWS Glue works really well with structured data, but most of your data stores will not just be structured data, right? You might have a data warehouse, you might have object storage, you might have files, so, and especially if it's an image, right? Everything goes out of bounds. Now you can't scan an image directly with AWS Glue. So you have to use something like textract to extract the text and then put it in structured format, then work with Glue. So it's just too much of an headache, right? Another example is PII Catcher. So it works really well, it's very fast, but it only works with MySQL, Aurora and Redshift, right? So again, object storage goes out of the window. If you want to scan Databricks, it goes out of the window, right? And then we also evaluated some commercial platform. So OneTrust, BigID, Borneo, and some other ones as well. What checked most of our boxes, the scope for which we had defined our data security program to look like. OneTrust checked most of the boxes, right? It gave us a central pane of visibility for all the data stores that we had. We could have one single UI interaction with or integrated with all of our data stores, right? Define one single scan profile which will have all the classifiers that I'll need, right? Be it name, phone number, email, Aadhaar, PAN, whatever, and use the same profile across all our data stores, and it will seamlessly take care of it because I just need to click a few buttons, integrate it, and just run a scan, right? So that's what OneTrust did for us. Provided a central pane for visibility, right? It of course performs data discovery and classification, and has built-in data cataloging capabilities. What it means is it can automatically tag and catalog data stores based on the data fields that it identified. Hey, this database, this S3 bucket has PII data. This particular data warehouse table has PCI data, right? So it automatically tags that the moment you run a scan, and it identifies the fields that are present within it. Once you've identified, or once we identified what data stores that we have sensitive data, right? One of the next steps that we took up was data masking, which essentially means that when that particular field, particular column is accessed, it's redacted or it's masked, right? Such that the actual data within it doesn't get shared with, let's say, a developer who might have elevated access as compared to like a customer, right? So to solve this for RDS instances, we used an open source tool called MaxScale Proxy. It's essentially a tool that sits it's a DB layer firewall, you can call it that. It sits between you and the database essentially, where you can put in configurations, right? And that configuration is where you can define, let's say, a global level masking. That hey, if a field or a column called name is present in any of these queries, right? Just mask that particular column, and it's as simple as that. Another one points of our concern was Databricks, right? So Databricks also thankfully comes in with built-in masking capabilities. If you want to try it out, if you have ever worked with Databricks, you can use this function called mask, right? In your queries, and it will mask the data or the column that you pass through it. And primarily Databricks having this functionality allowed us to like enable our analytics and business teams, right? Because we didn't want to block them and like essentially block all access to the data that they were supposed to use and have their job, do their job, right? But it did allow us to ensure the controls that we wanted to build and maintain over our data stores. This is just another example. Another popular data warehouse is Snowflake, right? So depending upon the data store that you're trying to use, this is fairly simple or fairly complex, right? If it's a built-in capability that the tool has, I would suggest to leverage it instead of having to write your own custom integrations on top of it to solve for it, because it just adds more complexity unnecessarily and you have to maintain it. So it's fairly simple in Snowflake, right? You just write a policy and then you apply it to a table and you're done. You're done for the day. So after data masking, the next step is access control, because data masking alone is not sufficient. Just because, let's say, a particular field is masked doesn't mean that everybody should now have access to it, right? And second of all, sometimes it's not even possible to mask the data. For example, how do you mask data that's present in an object in S3, right? So access control is one of those legs that we had to solve along with data masking, right? Moonlight is a tool that our DB team internally built from scratch, custom, to enable access to databases while not allowing any dev, engineer, tester, whoever it is, to have direct access to the database, right? So they always log on to something called Moonlight that we have internally at Cred, and that's the only place that they can connect to the database through. Of course, SSO and IAM, right? So depending upon the data store. So now S3, you'd have to implement something like IAM-based, role-based access control with IAM. And segregations can be done on multiple levels, not just environments, be it stage, production, testing, right? As well as the teams. So again, not dev teams or testing teams might not need access to the production data for testing, right? And so forth. So ideally, you'd want to restrict it as much as you can, especially for the data stores that you have marked or tagged as containing sensitive information. And as your org matures towards the data security legs that we've talked about previously, the one of the last steps or the most mature step would be to implement a federated data governance process, plan, whatever you want to call it, or team as well, where you define the policy centrally, because as Rashid mentioned, it's not feasible to just drive data security holistically from one small team, which is like security, right? Even if you have a dedicated security team working on it. So the idea is that the policies are developed centrally. They, let's say, from the regulations that you have, the controls that you want to implement yourself in your org, you develop these policies centrally, and then you propagate it forward to all the relevant teams, right? Which will have something called data stewards, who are essentially accountable and responsible to ensure that these controls are implemented adequately, and they become, let's say, an extended branch or extended leg of the security team itself that enables this through the entire org, instead of having the security team to run through all of the teams and then us having to figure out, hey, whether this was implemented or not, right? So these are some of the masking outcomes that we had. So this is, of course, one of our RDS databases where the email field is masked, right? And this is Databricks, where you can see the value column was essentially redacted. Uh, to quickly wrap up, some of the key takeaways are like, I mean, we already have a lot of teams, security teams, right? Application security, cloud security. And one might question, why couldn't data security fit under one of these buckets, right? So, I mean, some of it might overlap, but the thing is, the responsibilities and the end goals of data security differ a lot eventually once you start to mature, right? And thus, it cannot just be contained within application or cloud security programs at your org. So you have to have a dedicated data security team to maintain, look at the regulations that are coming in, for example, to translate them into controls and actually understand how they fit into the business context that you have at your organization. And to also, the data security journey should also start with an extensive threat modeling exercise. So you cannot fix what you don't know about, right? So to begin with, you should always take a look at your own environment, the data stores that you have, how they interact with different services, how they interact with each other, how is the data handled, what is the data lifecycle. There's a whole lot of questions that you will have to ask your org and your data owners as well, to figure out where do you stand at the moment, so that you can continue on to fix whatever you're supposed to fix, right? And I mean, of course, any organization that can be considered a data fiduciary at this point will have to have a data security program. At the end of the day, it's not an optional thing anymore. DPDPA is, I mean, for me, a tongue twister at this point. Is just too many iterations for this acronym. But it's going to be a mandatory requirement now, because there's fines as well. So and before embarking on data security solutions, it's imperative to thoroughly understand your organization's maturity level. It's the same thing essentially. Where do you stand at the moment, so that you can know where you want to go, right? And also the fact that if try to stick to the tools that you already have at hand, instead of trying to build custom solutions, because there's just too many edge cases and there's just too many things to do when we talk about data security. And once you start to mature, managing all of those processes end to end from scratch becomes a very tedious process. Yeah, of course. So data access controls, data masking controls, all of these security controls will not be one size fits all, because of how different data stores work, how they interact. Even like something like Postgres versus MySQL, both of them being RDMS, might differ on how you end up implement masking or access control on top of them, right? Because some native controls might be there in Postgres while it might not be there on MySQL, something like that. And at the end, of course, like, security is not about being an obstruction or being a blocker. The ideal way to go about doing this is to implement those controls in such a way, or in an elegant way, that any team that is affected or at the receiving end of those controls do not get obstructed or blocked, right? They can still do their job while you ensure that security is maintained across the org, right? So that's pretty much it from me and Rashid. Any questions or queries that you have, we can take it right now. Yeah. Uh, it depends, right? If you want to mask data while in transit, when you make the query versus if you have a mask column already. So again, masking can have different strategies, right? Let's say you have an email column. One way to go about doing this is you can create a new column that's called email underscore masked, right? So while querying, you can query that thing directly, and it will not have because it's an async task, right? At the end of the day. Versus if you want to mask it in transit, it might have an impact again depending upon what kind of data, what volume of data you're trying to query.
So on the if somebody is querying on the front end, obviously you will not give that logic to masking on the front end and get from the back end.
Okay, so when we talk about masking internally at CRED, we were talking about head users, right? Services will, at the end of the day, need to have access to that. For example, when you log into Facebook, Facebook does need to show you that, hey, let's say Ayush logged in, right? So that data does come back and it's stored in plain text somewhere at most of the places. But the idea is, let's say a developer internally at CRED, for example, should not be able to see your PAN number just because you shared it with CRED and I'm an employee at CRED. Right, so we were trying to solve it for head users as the scope. Sure.
Hey, it's a very valid question. When we started with this data masking is how do we achieve that? Thanks to Harish, by the way, for all his ingenious ideas and help. Uh, so there are multiple ways you can do the same. We have seen people handling it at the code level itself, so that any sensitive data comes, you have a separate logging library which does some magic to it and stores it in a different data store. We have seen people doing, for example, is a relational database. One of the column which has all the PI or PCI data will get stored in a separate database, and there will be a hash value associated to that. So there are multiple ways you can achieve the same. The way we did it, we solved it for head users. I mean, when I say head users, I mean developers, because we didn't feel the need that we need to add an additional layer of data masking. So we didn't do data masking at the source itself. The data residing on the RDBM is it's still the same. Nothing has changed. So the application can directly query it. There will be no lag. But if an engineer wants to query that data, engineer won't be able to reach the RDS instance directly. He would have to go through that proxy layer, right? But it depends on your org complexity. What are the goals you have? You can choose different solutions, and different solutions comes with different kind of costs. Yeah. So you need to see what fits for you. Yes. So there are two kinds of encryption basically. One is encryption at rest and one is encryption in transit. Encryption in rest would be provided as a default feature across all the databases. When we talk about encryption in transit, majorly we rely on SSL or TLS. I think that's a good enough standard to rely upon. Yeah. Sorry, I didn't get what you mean by endpoint encryption.
I mean, it is the whole packet, whichever is
Correct. Yes.
in
Yes.
transit
Yes.
is completely encrypted,
Yes.
and it only gets decrypted at your database level or
Correct.
data warehouse
Yes.
level.
Yes.
Right?
Yes.
I am Prashant. So I'll briefly discuss a scenario. For example, if we have in CRED, let's say, data about the salary and other financial data, right? And those data are supposed to be encrypted, as you said.
Correct.
Now we are keeping it encrypted in TiDB, and APIs are also encrypted, right? Now, problem with the system is somewhere on the UI you need to decrypt it. Probably in logs also for debugging purpose.
Correct. Yeah.
You need to decrypt it.
Yeah.
So in a way, developers would have access to those data in some way or the another. For example, if it in log, it's there as decrypted format, or on the UI purpose, on UI it is there on decrypted way, right? Somehow, right? So how do you manage it? Any
It's
suggestions on it?
a good question. See, the catch here is that you can't absolutely deny people giving access to data. So you have to identify your key risks. Where is my most sensitive data lies? Am I doing justice? Am I doing right, if you ask a question, by giving access to this data which is not needed? If it is needed for a legit purpose, you need to have access to data. At the end of the day, as you said, employee salary details, somebody would take a look at it. The HR would take a look at it who processes the payroll. So you can't stop it.
HR is fine, but devs are not, right? So they'll start having one-on-ones with their managers, right? I saw his salary. And
devs should not be able to. So this problem cannot be solved by encryption. This problem is an access control problem. Yeah, RBAC problem. If devs are able to see salary details of an organization, it's a huge access control authorization problem. Yeah. Yeah. So, yeah. So their access control has not been set up properly. That's what we need to do. Encryption will not solve the problem.
it's not exactly ERP. It's, for example, if I have a product which has the salary details, so which has the financial details. For example, even in cred, one of the customers can be one of the employees, and they would have some financial details in the DB, right? And then APIs would expose those details somehow.
No, but the way it works is for the internal employees, there's a complete different product. It's not a microservice. It's a tooling hosted somewhere which people do not have access to. And for application purposes or microservices, there are different DBs. They do not talk to each other.
And we don't collect the salaries of our
Yeah.
as simple as that. Have you put your corporate email where your payslip comes in as a credit? This is an original credit. We don't actually, so though you give the permission to us, we only have, like, we only scan for the credit card bills. So there is a difference. What is saying that employees are also customer of that, right? So yes. Then
Eventually, you have to expose the APIs, and then, or you are doing decryption at the front end and on the client side. If you have encrypted data in transit, so somehow or the another, you are sort of.
No, that's what I'm saying. No, encryption alone is not enough, be it REST or transit.
Yeah.
Access control, encryption, both works together, access and authorization. So if, let's say, I want to give this person access and he should not be able to access because he's the right person to see that data. So that control should be enforced, right? Whatever tooling or service you're operating at. So that's what I'm talking about. Just everybody shouldn't be able to go and see that data, at least in cred. We have not seen that, yeah. If you generally ask me, I don't see a use case of doing multi-layer encryptions. It's just a ad hoc, might add more latency and add more cost in terms of compute. If you're using standard encryption along with standard practices of access control, I think that's good enough.
Hey, Sarvesh. So, do you guys like have this proxy solution that you have for the user to access the data?
Sorry, where's this question coming from? Oh, yes.
Yeah.
Okay.
So,
Yeah.
is that proxy fully hosted by yourself?
It is hosted by us, but it's an open source solution.
So, any plans to use like private link that, because this is a solution AWS brought up, that you have a VPC and a second VPC, and you have a private link between them,
Yeah.
and not everyone can go from one VPC to the different VPC.
Okay.
So, have you guys planned to use?
I think that's a different problem you're talking about. You're talking about that there are two VPCs, basically there are two LAN networks within your AWS cloud,
Yeah.
and nobody should be able to take a look at it. So you connect via this direct link,
Private link. Yeah,
private
okay.
link. Okay.
Yeah, you can say,
Yeah.
but it can be a very good solution for having a very small access-based control. Like basically, it comes on the principle of least access.
Yeah, we do use it. especially if you talk about, there's something called VPC endpoint as well.
Yeah.
You must be aware.
Yeah.
VPC endpoint ensures your traffic is flown through AWS networks and not through the public internet.
Yeah. Yeah.
Yeah.
Correct.
And on VPC peering as well, you can define controls.
Yeah. VPC peering was a old
Yeah.
solution, but now
Yeah.
like they have come with
Yeah.
a new thing.
Yeah, transit gateways are there now. Yeah.
Yeah. So like, yeah, basically like the solution that you're hosting, maybe if you are using the whole cloud infrastructure as AWS, maybe you can try out.
I think we are already doing that, but for that we don't have a use case.
Okay.
For example, for the production VPC, there's one VPC, and nobody else should have access to that VPC. Is essentially.
Yeah, VPC cannot be accessed anywhere.
Yeah, yeah.
And ideally, we have separate accounts for.
Correct.
Since we CRUD is an umbrella for different regulated entities,
Mhm.
each with its own regulations provided by the regulators like RBI, PCI, IRDA. There are multiple regulators we work with, and each of them has its own requirements, and each of them requires separate accounts. So, and the access and rights within those accounts are also like restricted based on multiple.
Okay.
Yes.
Probably I would also like to know, while you were doing this and all, what was your hit counts and when it went to production, and how did you scale your platform to deal with such a large amount of hits in the
Okay.
peak times?
Okay. Talking about hit counts, we didn't encounter this problem exactly. The reason why, if you do the data masking at source, for example, if this email address of the customers you're storing in your database, and you're doing data masking at the database itself and storing the original information somewhere else and storing a hash value of that. Many people do that. When you implement that kind of solution, then you have to think about scale and latency and everything. We have not done data masking at source. What we have done is we have ensured that the RDBMS instance cannot be accessed by anybody. And we have solved for data masking for engineers and developers who are accessing those databases via proxy layer. So they have to go through a proxy layer, right? And app traffic will not have to go through the proxy layer. They can directly hit the RDBMS. So the scale is not a problem here. Yeah.
So I have one question. So let's say you get one ad hoc request. So you said some data are masked, right? Like PAN and all. So you get a support request that something is not working for a customer, and a developer wants to know a PAN details to debug that. So how do you deal with that? What is the
Hey,
process?
valid question. This is gonna come up in every other org. You can't 100% block people. So we talked with engineers and figured out a way. So the way it works is, by default, any sensitive data is blocked, and we have proper logging and monitoring as who is extracting what data from what database. Everything is collected into same solution. We have alerting and response based on that. Apart from that, to answer your question, we have come up with a policy along with the different teams, as if somebody has a very strong business requirement, first you need to justify why you need access to that data. It has to be a very strong business requirement, and you have to put that details, for example, in Jira ticket, right? Your manager will approve that, and then security team or database team will approve that, and then you will be given temporary access only to that column or table for a particular time period, for example, 1 hour or 2 hours. And then automatically that access will be revoked. So such mechanisms, yeah.
Done by that employee will be logged.
Yeah, and whatever he is doing, that activity will be logged. So we know what queries he ran, what data he extracted. And all this have to be automated, right? One thing you have not talked about is the extent of automation we have done here. Is if you don't automate it, it's going to be nightmare. So all of such processes have to be automated. From a technical standpoint, also from a process standpoint, you need to understand what are the caveats within your org, and how do you define such policies which works the best for you.
You-
Sorry, how do you? we don't populate staging or dev environment. Uh, uh, I mean, as a part of security team, my job is to ensure production data does not flow into any other environments. Production data is staged into production. For testing purposes, uh, uh, they have done some magic, but I'm not sure what it is.
The employees still have like private data, which employees can sign up to provide.
Okay, yeah.
Basically, eat your own dog food kind of.
So whenever there's a release going on, employees before it goes go live, we have something called as dog fooding beta release within employee segment itself, where we have a different staging environment. They do all the testing on the employee segment. We have more than 1,000 people, so.
Okay. Okay. So for millions of users, you are testing it on 1,000 users.
No, I won't say that's correct. Yeah, that's functionality testing. What we're talking about is load testing. Load testing happens from the QA perspective. They have some automated tooling deployed, which huh.
Synthetic data for like say,
Hmm.
we do generate Meetup or theoretic test methods to generate synthetic data to do bulk testing
Okay.
for like large volume.
Yeah. Sure. Harish, are we taking too much time? Anyways, I'll answer this. Uh, when we talk about ransomware, it is basically a class of malware or virus. Okay. So it has to come from somewhere. Okay. We consider both outsider and insider. Okay. Most commonly, it comes from internet, either via phishing email, or you download some infected file from the internet, and most commonly it gets executed on the system itself, laptop itself. Okay, and once it is there, executed there, then it will try to encrypt all the files, ask you for ransom to decrypt the files, try to spread across different networks and systems. So for laptops, the best way is to enforce security controls on the laptops. What has been working for us is next gen EDR, is what they call it right now. It's a fancy name of the traditional antivirus is what we used to see. So these are working on fileless malwares. Malwares have evolved right now. Signature based detection does not work anymore. So EDR provide behavior based detection. If a file is behaving in a malicious way, just quarantine and block it. That's been working for us. One more way where a ransomware or a malware could come within your system is, let's say you have given an option for users or customers to upload any file which you can view, which the backend or support team can view. For example, I ask you for a PDF document, right? And my support team is opening that document and validating some details, right? And there are a lot of ways you can attach a malware to that PDF file, and the moment your support team opens it, basically you're done with. So to avoid that, we have deployed a cloud-based anti-malware solution. So any file which is coming from a untrusted source will go through a malware scanning solution and then only be uploaded onto our file storage wherever we have the file storage solutions available. So I think the very simple idea or principle in security is to do not trust anybody, especially any input coming from an untrusted source has to be sanitized or has to be checked. So if you secure your laptop's endpoints correctly, plus you ensure that if any user is allowed to upload any file or data which your employees can see, that has to go through a layer of inspection. I think that would be good to go. Okay. Sure, we can take later. We're open to all kind of questions. Uh, Yes. Harish.
So now we have Sriharsha and Harpreet from Thomson Reuters Lab. They will be talking about enabling business transformation with LLMs at scale, challenges, roadmap, challenges, risks, and the roadmap ahead for solutioning using LLMs. Stage is yours.
I just want to clarify, I'm not Sri Harsha, I'm Shirsha. But it's fine, Harish. It's fine. So, while Harpreet is still setting up, why don't we do one quick interactive session? What did you use ChatGPT for today? For scripts. Write the script. Stack Overflow. It's the new Stack Overflow. Okay? Huh? Avoiding it. You're avoiding ChatGPT. Why? Oh, okay. Okay, your security, you're from the security team? Okay. Okay. Any other use of ChatGPT that has worked out for you today? Writing? Writing content. Okay. Okay. Any other? It may be even your personal usage. I mean, just something interesting maybe. It gives me an idea for the weekend. I don't know. Yeah, absolutely. It helps us prepare for the presentation. So when I think Sharmila asked me, give me an abstract now. So I went to ChatGPT. I said, ChatGPT, give me an abstract for an LSPE talk. It should have this, 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 and it should conclude with this. That's it. I was done. I sent her that. Really, I'm not, even joking. So what I wanted to do was to tell you a small story today about, we had this spark of imagination. We had this idea coming together sometime in March this year. We wanted to build a playground, and we wanted to do like an in-house ChatGPT. We wanted to do like an in-house ChatGPT. And why we wanted to do an in-house ChatGPT? One, I think we were mostly intrigued and curious how this is going to pan out. We didn't think too far ahead. We definitely thought this is going to be something cool to do, interesting to do. And more importantly, to that gentleman's point, we thought it's going to be this safe thing to do, right? So what I wanted to tell you was, this was our big idea that, like how ChatGPT is there for the world, let's create a ChatGPT-like environment for our company, right? And there were several doomsayers in our organization. Why are you doing this? There's already ChatGPT. There's Hugging Face Playground. There's Azure Playground. Do you really need to do another one? All of that, yes. All of that, yes. But I think we still wanted to do it. Right? There was this, I think, grit and push that, okay, we are going to do this cool thing, come what may. And so that's how I think Open Arena, as we called it, was conceptualized. But more than anything, I think we thought that this is going to be a new world, right? It's going to open up a space for the entire organization and for almost every role within the organization to actually explore what AI can do for their space. Not just developers using it for Stack Overflow, but every single employee we felt had the need for AI. And so that's why we conceptualized Open Arena. Here's a screenshot of Open Arena. I think Harpreet's replaced my screen with this is with the Llama 2, right? So we launched it with the Llama 2. I'll tell you a bit about each of these styles, right? So this goes through a release cycle every other week. But what we do as part of Open Arena is people, as soon as they log in, they're able to see the screen, and they're able to try out each of these experiences which are backed by large language models, which is your ChatGPT's backend. Llama 2, you may have heard, this is the open source large language model from Meta. We've got Ask Julius, which is our internal Stack Overflow envisioned almost. Today we are not quite there, but at least, if you want to look at tech stack or any other technology related information in-house, this is what developers could use. Ask PL and Ask Checkpoint are, chat-based interfaces to few of our products. PL stands for Practical Law. Checkpoint is tax-related questions. This style lets you upload your document or paste your content or your PDF and ask questions, chat with it almost. This is, every new large language model that comes up, we try to, give it a space here. Sometimes it is also something that we may have curated and built. Azure OpenAI is, of course, your GPT 3.5. We have some specialized styles as well to do summarization or, any other such experiences. There's more, which we didn't put here, but, there are ways and means to do more experiences that people have come back to us and saying, hey, we can do this with GPT. Can you add a tile to that? And so this is, exhaustive list of what you could do with AI, right? Now, why Open Arena? Okay, March, yes, our reasons were very different. But if I look at where we are today, I would say we've built Open Arena and we continue to add to it and we continue to keep it up to date for these 5 reasons, right? One, and most importantly, it's the safe and secure place. We're just coming out of the security topic, so it's the safe and secure place to really play with AI, right? And what this has enabled is it's given this freedom for every job role to really try out AI and see what it could do for their space, right? It's flexible and accessible, so you just have to log in. It's not a programmatic access, which means content creators, which means bloggers, which means sales and marketing. We've got pools of legal editors and tax auditors, so it's easy for them to access and see what AI could do for their space. It's easy to use. It's educational because sometimes the AI tells you, next steps, right? Tell me how to do this. So AI tells you. It's collaborative. People can get together and build over each other's ideas, right? So this, in a way, I would say, has actually accelerated the AI adoption across different teams in our organization. I want to take you through maybe, few of the interesting outcomes from all that experimentation that we've enabled. Let me start with some which are not listed here. So Thomson Reuters, as you know, Reuters, the news agency, has huge armies of journalists. And how might journalists use AI? Any ideas? How could journalists, from small content, they could write bigger content? There are, I think, some laws around that. I don't know if you want to do that. And also, they would find it insulting to do that, I think. Any other ideas what they could do? Research about a particular topic, exactly. So what I've not listed here is that our journalists have actually been the first set of non-tech users who've embraced AI like anything. Their biggest use is as soon as there's a news alert, they place the news alert with our GPT interface to ask questions alongside. Right? So if there's an oil spill somewhere in Finland, so they say, give me 5 questions related to this. Okay? And so which means there are 5 background areas of research they could probably be suggested by the AI. And now we've combined this also with the Reuters corpus, which means that they could also do that background research without hallucinating. Right? So it'll be even safe and proven content that they themselves have generated. And so they have background research which could also back that article that they're looking to write. How are our sales teams using this, right? So I don't know about how tech-enabled your sales teams are, but when I speak to people in Amazon, which is one of those tech giants, and also to sales teams in Microsoft, I find that sales folks always have to scramble between contracts, CRM systems, and other in-house systems, right? So for example, in our case, our sales teams needed to identify opportunities for upsell, and they leveraged AI to do so. AI would first go through contracts of customers, identify clauses where product usage had thresholds and limits, and look at actual product usage, which is again in different systems, and then correlate that to be able to suggest ideas for upsell. Now, this sort of an activity which I described to you in half a minute takes them a month, because contracts are many, and they are sometimes scanned PDFs. They are not so searchable, right? But I think with the AI that we have in place today, and not just large language model, but also the OCR space has so evolved that we can now just chat with an entire folders or S3 locations of contracts, right? What's more, so if you have a question like, tell me which is that customer in my ANZ region which is using the product beyond the minimum threshold, which means I can target that set of customers for an upsell, right? Or tell me which customer is using my Reuters video content in a channel which is not authorized. So there's no automated way today which looks at what does that contract have, which of the channels are allowed, and is the customer using it in a different channel, right? So I think these sort of chat-based enabling of this flow, I think, is much more simplified today, right? Our marketing teams are using the large language models to sort of build up strategies even. Maybe start with, give me an idea of how I might do this, but they also allow to sort of template it. Give me something for this slide, and then give me something for this slide and this slide, right? So I think this is again very similar to how I might make an itinerary, but almost there. Stack Overflow, I think some of you mentioned you use ChatGPT for Stack Overflow. We are looking at this bit, like we showed you Ask Julius, which will enable developers to find out quick answers to their technology doubts. We think that this combined with what we have as code, the code llama, right, could almost fulfill our in-house Stack Overflow needs, right? Which would also mean that we will curate a community of developers who answer each other's questions. We're doing this use case with the customer support teams where they can very quickly chat with huge volumes of knowledge-based articles and, let's say, recently solved tickets to be able to answer customers' questions, right? And of course, with HR, we are doing, chat with my policies and the rest. There are, many more teams which have been leveraging AI to sort of build out their efficiencies. I would say our content specialists. We've got, armies of legal editors who are actually, let's say, attorneys or lawyers. They've been using AI to sort of see if they can do the sort of editorial activities they need to do. Our publications, our legal publications that TR produces have to be formatted. The language needs to be rechecked. So all of that is what we are also using AI for. With that, I think I might hand off to Harpreet. He's going to tell us about the architecture of what's built.
Hello, hi everyone. So thank you, Shisha. So I will talk about the architecture of OpenRena, although different tiles might have different multiple applications, but this is on a high level. This is the whole architecture. So most of the services we are using are on AWS, and we're using mostly the serverless tag to do our all processing, as you see. So when TR internal users, our employees log into the platform, we are hosting our front end, which is a basically React application on S3, which is fully scalable. So we don't need to worry about the serving part of that in a bit. Along with that, it is connected all the APIs that we call from the front end, the model APIs, as well as the call to the different endpoints are managed by the AWS API gateway. Here we have enabled our single sign-on auth, which our third party, so for example, which is enabled via Cognito, which helps ensure that all the users who are logging into a platform are TR internal users only, not any other contractors or any outside users. So here we check those users. Further that, we have a couple of lambdas, which does the inference step. For example, if you talk about maybe call to on a chat GPT model, which is an Azure OpenAI. So when the users log in and select the tile of Azure OpenAI, it will just directly call the third-party API from Azure Open API. And similar to that, if the model is hosted in our environment, for example, Llama 2, so that are all the models that are deployed on our SageMaker environment. So SageMaker is mostly the backbone of all our solutions here. Most of our models are deployed on SageMaker. We have different models deployed in real time on Sync. I will talk about that later, but that's the flow. We even allow users to request logs. It's we have written log, but it's basically that, okay, all the queries that you have made to ChatGPT, if you want to download them, you can just request for your logs and you can get all your queries based upon your date timestamp. A user can get their thing. This is also helpful for us to do model retraining and feedback, which is all this database, and we are storing them in the DynamoDB tables. Similar to that, we have an Ask document pipeline. If you see a previous slide, there was a tile to check if you could chat with your documents, like if you have a PDF document or a doc which you want to try and chat with them. So that is a flow which has the indexing, searching, and we're using OpenSearch for that. And then once the document is received from the OpenSearch, it is sent to the call to one of the model. It could be in-house model or open source model or an OpenAI. That's all. So now, after the architecture, let's talk about the challenges that we have to make this enterprise. So the first of the challenge that we were having was load testing, because to support all the users in TR and with the complexity of models that we have, we need to have the load testing that, okay, it could support X number of users at a real time when we have the peak traffic of internal traffic. The second was being cost effective. LLMs, as you know, require large isolated infrastructure. With large isolated infrastructure comes the GPUs and comes a lot of cost. So being cost effective was also one of the measures that we have to make sure that the most of the right sizing of resources and all those things is being done. The third, which is mostly solved now, but we will talk about the bandwidth constraints or OpenAI. Azure OpenAI still has some bandwidth issues with the latest model, for example, ChatGPT 4. And they have special quota for that just to make sure that every user can use it. So we have model deployment in various endpoints. So we need to, our users were affecting with the request per minute limits of that request is reached for them. So we need to intelligently handle those in our environment so users don't get affected with the rate limits and all those things. Second last is the chat response. So a model LLM call, a normal LLM API call could be served in like a 15 or 13 second max, but LLM call could go more than, based upon the number of context on the based on number of documents you're passing, it could go more than a minute. So we need to make sure that the responses in the chat interface that we were having need to be timely response, like quick, as soon as possible. And then the last one was to adapt to the rapid evolution of open source LLM. Every third day there is a new model that is in the open source market, and we want to try it with our environment as well as our TR data set to make sure that what are these applicables in different environments that we have. Yeah, these were some of the challenges. And the next slide we will talk about how we resolved each of them, or I would say we are still working on some of them. So the first one is of achieving low latency for chat responses. So we have two approaches mainly basically here. The first one is that all the LLM models that we had deployed, we make sure that we quantize it bit. So that process takes care of that reducing the memory footprint of the model, as well as if you reduce the memory footprint, it also reduces the cost, and it also increases decreases the low latency of that part. So the only thing we have to make sure that the performance or the accuracy of the answer doesn't get degraded. So a right combination finding is a very crucial factor here. So the second thing that we did on the moving was that initially when we started this solution in March, this whole solution that you saw on the first slide of architecture was using REST APIs. So AWS API Gateway that we're using, our API Gateway has a hard limit of 30 seconds. And some of the responses, if like, because if you're chatting and when you're sending a request, it also has to send all the chat history to set up the context. So the request to model could take more than 30 seconds or maybe near about 50 seconds also. And so now we moved all our endpoints to the streaming or the WebSocket. So we moved it to we are still on AWS API Gateway, but we have moved to a WebSocket API Gateway. And that ensures that, okay, as soon as the user starts the question, it starts getting the answer word by word. And it could handle more than 30 seconds workload also. Second thing was load testing the whole OpenRHINA solution, or I would say specifically the model part. So for the normal load testing, we were using Locust as a load testing tool, which is working good for us. For the REST APIs, we only wanted a solution which could load test not the like how many number of hits are passing and how number of hits. We also wanted to capture a couple of advanced metrics like the model metrics and the responses in different methods, like maybe in a CSV or a files, which could be done for the evaluation and which could be used for later also. So Locust, as in Python, it could be easily expanded to do these things, and we were able to, with our custom logic, we are able to use in our testing framework to make sure that once the models, once we onboard or select the open source LLM or any other one, it is properly load tested. Now we have moved to a streaming. Unfortunately, Locust doesn't support by default the streaming or the WebSocket part or the chat interface part. We are still looking into multiple, I would say, tools. I'm implementing like K6 or Artillery. This is something which is still in progress, and if anyone has any recommendation on that thing, that will be really helpful for us. Yeah, and that's all for loading. And now coming to the scaling techniques. So, Shisha, can you go back to the architecture slide again? Yeah. So as you see, most of our AWS services, I would say, mostly are using serverlesses or managed services from AWS. Like for example, Lambdas, we don't need to worry much about the scaling aspect of those. Similarly for S3 and all those things, although there are some, but for example, for some of the Lambdas, we have enabled provision concurrency. So we make sure that we get ultra low, we get the model is already from then, the user doesn't get the cold start when the user asks the question. But for the scaling aspect, we were mostly focused on the SageMaker model part and OpenSearch and DynamoDB. So I will talk about the SageMaker model scaling part. So we enable, so by default, we are using SageMaker real-time endpoints. So real-time endpoints, you can enable auto-scaling policies. Although there's some constraints that will come in the async part, but yeah, we have enabled auto-scaling policies based upon the invocation metrics as well as the latency metric. So choosing the metric to which one to enable auto-scaling is a crucial one, which is something linked with the load testing. Because if we have to, like for example, say of the Llama 2 that it need to be scaled to this number of endpoints, we need to ensure that it's currently deployed on G512X instance, which has like this much of GPUs and this much of GPU memory, and how much traffic it's able to handle. Similar for the latency metrics. So we use both combination of these two metrics, the invocation metrics as well as the latency metrics, to scale our model endpoints. And then for OpenSearch, it's basic scaling. We are doing a horizontal scaling here based upon that. And the DynamoDB, it's auto-scaling enabled based upon AWS, mostly handles those part at their own. Based upon the usage and all those things, it updates the read capacity and write capacity units. Yeah. So for the, just a minute, okay. So for the scaling, there is also one more thing that we're doing. So for some of the events where we need the traffic is already expected, like for specific peak hours of the day, we automatically scale up, we scale up the environment to a set number. So we could, those users could not be required to scale up, and it could directly handle all those requests. Can you move to the next slide? Then the performance monitoring with Datadog. So this is one of the very crucial factor. Initially, we were very much focused on building the solution, like integrating more and more models, adding more tiles and more features and use cases. But later we have also implemented it with the performance monitoring. It includes on all the endpoints, like for example, the metrics, the APM level call. Like for example, if there's, while we were optimizing it for speed, we need to make sure that we enable tracing, which is similar to AWS X-Ray, that okay, how much the call is going and how much time it is taking on every call. So we have the complete monitoring of the OpenRena platform on Datadog, which includes Datadog dashboards, and it's already integrated with our Microsoft team. So just to enable that, okay, if there's any issues with that. This is just traditional stuff, but I still feel that's very much crucial, specific the APM part to optimize multiple factors in that. Then I will talk about the evaluation of open source LLM models. We have built, because like currently we have 4 or 5 open source models, but there were more, and we keep on rotating as the next big feature coming. For example, there could be Falcon, there could be Llama 2 at the best at the moment. So there could be new and models being in progress. So we need to have, we have created a model evaluation framework where we evaluate all these models based upon multiple vectors. Some of the vectors could be how much batch size it could, how much context it could handle, how it is, what's the cost per request, how it's a latency for that, what is the infrastructure requirement or the GPU requirements to run this part. And the most important part is that, okay, testing of that model based upon some of our use cases, or the, we would say, TR internal data, that's upon that, okay, which one is best for us. For example, if a model could be having very high accuracy, but the context size is still less, that could also be an option if other than that one. So here, this model source evaluation, I've not added the architecture diagram, but it's similar to a batch analysis job where we, which is powered by AWS ECS instances as a batch. And once the whole evaluation is done based upon our data, it sends the results to our team to analyze based upon certain factors. So this whole process is automated. And then on the cost part, as we discussed earlier, we want to make sure that all the costs, all the models that we deploy are efficiently used. So we need to make sure that control the cost of the solution also. So to control cost, the first thing we have done is to right size the models, as I talked earlier about the quantization techniques. So for example, we try to make right fit for the instances that we have and that we choose. And specifically from the AWS, we also use the SaveMaker savings plans, which could give us extra advantage on the cost part of that. And then on the cost management solutions, we have, if you have seen in the first diagram, the view of the OpenRena, we have a compare tab. So compare tab is basically that, okay, you have 3 or 4 different models and you have a query and you want to evaluate the same question with all the 4 models and you want to see that which one is the best one according to you. This is required most of our users also to, they could adapt as, okay, this model could be best for our use case and all those things. So this is basically an advanced type of users that we have. So for those users, we have been using SaveMaker async endpoints. So there's a problem with SaveMaker that the solution, SaveMaker endpoints that if there is no traffic, for example, on weekends, because it's a completely internal platform, there would be no traffic, endpoints could not scale down to 0. You need to make at least, SaveMaker doesn't allow, you need to keep at least one endpoint still up on that part. But SaveMaker async solutions, which is mostly a batch analysis type of thing, gives us the flexibility to make sure. So this is a solution which we have implemented and moving some of our endpoints from a SaveMaker real-time endpoints to an async one, which could help us there. Other than that, we have also implemented auto shutdown, and I would say not a shutdown, but yeah, it's mostly as I discussed that, okay, you can't scale it to 0. We have to manually have a logic for that. So what we do is that we have a service which automatically deletes the endpoints on the weekend and make sure that it's up on the before the before the week starts on that part. So that way, since we have monitored that, okay, there's near to zero traffic during the weekends, this helps us to save a lot of cost on that part. Other than that, I would say for the FinOps or for the cost management part, it is very crucial to monitor your cost. We have, not only for this product, we have set up a central dashboard which could enable us to monitor all the cost in our organization or team, you can say. So similar to that, we also use this for OpenRAIN and could help us identify that, okay, these are some of the things that are not used, and we try to combine these metrics with the utilization metrics that we have in Datadog to make sure that the whatever we're using, it's the right value to cost part thing. Okay, now to the last, working with Azure AI constraints. As I mentioned earlier, due to chip shortage or GPU shortage, you can say there is still Azure AI constraints upon the, so OpenAI Azure has a limited number of, it's currently available in like 2 or 3 regions you can set up it. And for every region, they also provide you that, okay, this is a certain number of TQM and RPS, the request per second you can send, or the tokens per second, tokens per minute that you can send in a request. So since we have multiple endpoints, but with different quotas and limits for that, we need to intelligently have a routing mechanism algorithm which could take care of this. That, okay, just for example, is that one is the fallback mechanism. Like for example, user is trying to open the OpenAI tile, and if the context is already high, and the limit is reached, it would automatically go to the second endpoint. Like for example, if GPT-4 limit is reached, it could automatically fall back to GPT 3.5 or GPT 3.5 Turbo. Similarly, we have multiple endpoints, as I discussed. Some could be in a different region, some could be in different regions. So we have enabled a bit of load balancing on that. We're using Cloudflare for that. To make sure that, okay, once we are making a request, it could be distributed upon the multiple endpoints, and we could equally distribute the traffic on that part. Yeah, that's all. I think that's all. Any questions? Yes, sir. Okay, then be that one first.
Hello. Yeah, we're doing something similar within our org. I was just curious, what was the need for so many different LLM models, given you have OpenAI GPT, which works really well? Was there a different use case for different LLM models?
You would like to take this question?
Yeah, OpenAI is definitely, silver bullet. It can definitely solve for all use cases. But I think, not everything needs that sledgehammer. Right, so there were instances, like for example, I mentioned about our editorial activities where we have a lot of, let's say, information extraction kind of activities. Those don't need a GPT call. They can do very well with an open source LLM. In fact, something not even so advanced like a Flantify worked brilliantly. And so we're still using Flantify for many of our information extraction projects. We don't need to go all the way to, so cost is definitely much less for the volume, and we are more in control of the outcomes. GPT, we are much less in control. One is availability, like you mentioned, it's not, there are bandwidth limitations. Added to which, I think, if the API version changes, your prompt and your necessary interface, right, that also needs to undergo minor changes. So I think given the different constraints, we found that using the open source LLMs worked best in some of those cases.
Makes sense.
Yeah, of course. And if you remember, he showed you the logs getting collected. So what we've set in motion now is going to give us enough feedback to help us do fine-tuning maybe a couple of cycles later.
Understood.
We wouldn't have as much control for sure if it was GPT.
But for example, if you're hosting this Llama LLM model in-house, are you using it as it is, or you guys have also tried to train it to your environment context?
Not yet, but we're also talking to some vendors, not as part of OpenArena, but as part of our other projects as well. We're talking to vendors where we could leverage their platform, like Mosaic ML and others, right? We could talk with them to see if.
Okay, thank you.
Yeah. Yeah, sure. Yeah.
And basically, journalism is about fact checking. So how do you check whether the model hallucinates or not?
So what is your use case? Like if you want to give answers from a set of facts, right? In which case you should not be asking that question to GPT. You should instead ask GPT, these are the facts from which you should answer the question, and only from these facts, give me an answer from these facts,
So
right?
it's
So that way you kind of ground how much it can hallucinate.
So you should train the journalist
Yeah,
to
it's
do
the
prompt
prompting.
engineering.
It's the
basically.
prompting, yeah.
Okay, and another use case which you mentioned was like on using sales data.
Yeah.
So do you train the model on your private data, like the data is you are
We
using?
don't need to train the model. So most of these LLMs that you see, nothing is trained by us.
Fine
They're
tuning.
Fine tuning also for the sales use case, we did not need to do it. So in the sales use case, if you see, we had 2-3 parts to it. One was, extract information from documents, PDFs, and contracts, right? Agreements with customers. The other one was to, maybe correlate that, set it up for a relational database and do Power BI with it, or correlate that with, let's say, CRM systems or product usage systems. Right, so we did not need to train a model. We just needed to mix, combine it with different systems. Yeah. Yeah, of course, we're using embeddings. Yes, yes.
We have also tried Wilbur's OpenSearch and some others also, but yeah, right now due to the we have also used Milvus and OpenSearch, but I think just for the managed services part, we're using for this use case we are using OpenSearch here. Yeah, you could, like for example, if I talk about OpenSearch and Milvus, you can have multiple collections in that, and for your use cases, Milvus also provides good ABAC and RBAC system, so you can control which type of access and which tile would get. But it is only used for specific tiles. That, for example, here it's for a normal chat interface where you just chatting with the model, that it doesn't require it. But for example, if you have to search in your internal data set, like for example, a use case where was internal Stack Overflow type of thing, where the answers don't need to come from OpenAI, we just need that intelligence of OpenAI, but question and answer should be ours. We will just give them a couple of embeddings, and they have selected, okay, based upon the intelligence, get the right answer to them. So in those cases, they are being used. Yes.
Yeah, so I have one question here. So like as Thomas Rooster is for global content creation also, so like adding to his question of fact checking, do you also have some evaluation methods to see like what kind of text you are generating and is it valid in the background?
One thing I want to tell is that like for example, I showed you the Ask PL, right? So Ask PL as a POC, when we created it in this open arena, what it did is the practical law content, which is, let's say, content around cases, bills, laws, statutes, all of that is indexed and stored in our vector store, okay? And so for every question which comes from the user, we convert it to embeddings, like he said, and then we fetch similar embeddings from the vector store. And we maybe use more models to sort of rank the embeddings which are found, right? And then we send that set to the large language model to give us a well-formed answer. Right?
Okay, so like how do you?
So the answer is only from the content. It is not from anything else that the language model has been trained on.
So basically, like it takes the data and it augments the answer with the
It just gives a well-formed answer,
okay,
such that it's friendly sounding answer. That's all. Yeah, it forms the answer with this. Like you can prompt it to say, give me an answer to the question which is this, which came from the user, from this set of embeddings, right? Which will answer this, and there are also guardrails along this flow, right? So it's not, this is what I showed you, told you right now, is a sunny scenario, right? There are cases where, like somebody's asking what is life, but your question is around what is, the law and bill and all of that. So your what is life kind of question should be, you want to hold it right at the start and say, I am trained only to answer this. I don't want to answer your what is life. You go here or something like that, point it to something else. Or if you want to entertain the funny questions, you can say, yeah, and then maybe open it out to your non-corpus flow. Like it depends on how you want to design it.
Okay, so
Sometimes we like to see the the funny questions.
okay, so like adding on to your thing of guardrails. So do you have guardrails at the front end and also from the LLM models also on the
Yeah, so
both sides?
So different solutions have it a little different, and sometimes we've needed to change it as well, like where exactly should we have that guardrail. Remember how I told you, like, we generate embedding from the user query and then fetch the top n searches from the vector store. Now, if those top n searches are not above a certain threshold of score, then maybe there itself we say, no, we're not able to find a match. You talk to a real agent, let's say. Right? So that's what we're doing for our customer support thing. Some cases, maybe we want to allow it, and then let the LLM call take care of whether it's a right answer to the given question. And if not, then give this. I am only trained to do this. I cannot answer questions around life, whatever.
Okay, like maybe like many users might ask the same question repeatedly. So do you have any mechanism to have FAQs kind of thing?
The cache we are going to do. We have not yet built it. So we think, at least for the customer support use cases, right? During busy tax season, we have like lot of questions coming which are very similar in nature. So we want to create a cache before we hit the LLM at all, or even do the vector store or anything.
Okay. Yeah. Thank you.
So I think these are obviously deep tech questions. Now, the thing is, there is one paper where it says that if Google adds a generative AI backend behind search, their monthly profit will come down from 55 million to 28 million. So have you done a calculation why adding this? Is there a cost increase?
Profit will come down?
Profit will come down for Google if they're going to add a generative AI backend to augment their search results today. So that's their publication. 55 million to 28 million per month. It's a large hit, right? Who is going to pay for it? So for your use case, have you done a calculation of that sort, that what is the additional cost, or it's like free money now?
No. So we'll keep this POC aside. I think I will tell you the story of Chegg. You know Chegg, right? Chegg is a edtech platform, a student platform where, let's say, for SATs or TOEFL or something, if you're preparing, they give you courses and maybe mock tests and things like that to prepare for. So their subject matter experts are like tutors and other such people who will help you prepare for your exams, right? For particular subjects. So when ChatGPT came, students didn't need to use Chegg anymore, right? They could just prepare. They could prompt ChatGPT to prepare mock test papers. They didn't need anymore a platform like Chegg. So Chegg's shares, I think, came down by 30%. Then Chegg decided to, pull up their socks and change the game. And then what Chegg decided to do was invest in fine-tuning large language models. So there's a biology model, there's a, maybe social studies model, there's a maths model. And now what they've done is they've backed their edtech platforms in different ways, right? So mock tests, yes, but also as a study pal. Okay, which is like your teacher who's always there monitoring you, answering your question, last minute doubts, or asking you questions, right? Vice versa as well. And all of that is backed by large language model, which means they've changed the tech stack that they leverage, but provide the same platform. And simply because ever since they said that they are doing it, they haven't yet done it, I think, I don't know. But ever since they said that, their stock prices actually went up by 30%. So this is just, looking at financial data and how, news can actually bring it up and down, right? So I don't know about Google's figures and, what it's based on. My company strongly believes, because our products are for lawyers, for professional workers, the knowledge workers, my company strongly believes that this technology has to be harnessed ASAP by every profession, right? So that's why we've pivoted almost all our products to leverage this in our tech stack. and I believe that we are on the right track there. So, yeah.
as you can see, is MLOps for demand forecasting by Manjush, who's actually a data scientist. He was started his, everybody attention please. Yeah? Okay, so the next topic is, as you can see, MLOps for demand forecasting by Manjush. He started his career as a data scientist in 2015 and is currently working as a data scientist, I mean, of course, grown, in MOB. And his specialization is in natural language models, customer cart analysis, and in demand supply models. And I think the topic is totally relevant related to demand forecasting. So over to you, Manjush.
Hi, folks. It's been some time since I spoke to any number of audience. Last time I had was a podcast. So the topic that I'm going to talk about is MLOps for demand forecasting. So this is something about me. I worked as a data scientist at Dunzo for past 7 years, almost 7 years. First 5 years, I'm the only one. In the next 2 years, I hired few people, and then I left Dunzo. I took 9 months break. It's unusual for folks, but then I joined InMobi. It's been 2 months. It's just been 2 months, so I can't speak anything that is related to InMobi. So this is something that I have worked at Dunzo. This is nothing related to my current company. The scale of Dunzo, when I left, it was around 200 million data points. So it might not be very large scale for some of the folks who spoke like last few talks, like some of them mentioned like petabytes of data. That's not the scale that I am going to be working with this. This is the agenda. Like I'm going to introduce very basic things like MLOps. Like most of you folks might have known like all the principles of MLOps by now. Then I'm going to speak about why I chose demand forecasting for this talk. What is the complexity? And what is the starting point for the demand forecasting before we introduce the MLOps concepts into our modeling, data pipeline, and production. And post MLOps, how does it look? How things became better? I'm going to use some of the things like Apache Airflow. Like I'm not going to go deep into any of that. 30 minutes talk is not sufficient for any of these. I'll start with the problem statement. Problem statement is very much similar to most of the Swiggy, Dunzo, Zepto, Blinkit. I think a lot of companies wanted to solve this. Like, this is not an individual problem. You're basically trying to take historical data, probably take some real-time features, and different granularities you have for prediction. You can take a geo level, city level. City level might be very easy. Geo level and even store level. This can differ even further with changing market scenarios. And especially for a place like Dunzo, it kept changing. We had dark stores introduced. There was inventory management involved. This is supply chain overall. It's not sufficient for us to say, this is the demand for next 30 minutes or next 60 minutes or next 2 hours. Unless we have the supply aspect of that predicted as well, we wouldn't know how to use our money, right? Let's say an area is there where the next day's demand we have successfully predicted, even with a lot of accuracy. But there's no supply available to deal with the demand, then it's all gone for a waste. You don't have anything built on that. Let's say you have something built on that. There is also offers involved, offers aspects. You are taking customers into this consideration. Like some customers order a lot, some don't. How do you sort of balance out? Like how do you know which customer to give more preference or less preference? There's also segmentation aspect to it, right? And a lot of these are involved in the demand forecasting. So it's not an individual problem as such. The folks that are involved in solving this problem is mainly business folks. Like you'd say anything that comes in any development pipeline, it needs approval from business folks. How do you do it? You have to present a POC telling that this is how things are going to work. The problem, I think more folks are involved. I just got distracted a little bit. So nowadays, mostly data scientists, ML engineer, there's so much of confusion in between roles. Data science folks are someone who build things end to end, but it differs again from organization to organization. But how we do things is we do the complete machine learning pipeline. We also handle bit of data engineering aspects of it, but we might not handle it fully. We might just be handling what is necessary for building an ML model and take it to production. We might not have other aspects like other data pipelines or ETL tools. We might not go into that. This is how a simple demand forecasting pipeline looks. Gather the data, pre-process, model training, model inference. This looks pretty simple, right? I mean, you gather some historical data and then you're predicting something on the near future. Now you try to get this into production. You realize that within 1 week, people are going to come running to you telling that this model is not working because there is no transparency here. The aspect of transparency is like this. You have built something on past data, let's say whatever, 60 days of data, and you gathered 200 million points. You can even go for like state of the art, whatever is best in that particular, let's say, multi-object time series model. But that even won't be sufficient to sort of say that it's good enough, because your data keeps changing. There can be some sort of drift in your input points. How it's working on an hourly basis changes on the live data versus what you have on the training. So how do we solve this? And business folks are going to come to you and ask for why a certain data point is not working in the way it is expected. Now, how do you answer this question? How do you tell that where is your failure in the overall data pipeline? Is it in the training? Is it in the inference? Like, what is going wrong? So these are, again, like the stakeholders, right? Like, they speak in a very different language. Business folks, they were like, mostly be like, what's the amount of dollars saved by putting this into production? And the language of a data scientist is very different. They can give you metrics like WMAP. WMAP? What is WMAP? They had no idea. And if you take machine learning model, like it's a lot of knowledge that you probably need to make business folks understand. So it's rather easier to make some things built in some sort of platform so that it's easier to communicate to them in a scientific way. How do you do that? We start imparting some of the concepts that are very well known in the industry now. MLOps is this very fancy way of telling we are going to automate like the CI/CD pipeline, and obviously we are going to include one more thing called CM, continuous monitoring as well, into the cut. How many folks have worked on TensorFlow extended here? Can you raise hands? Just 1, 2, okay. This has been there for a very long time, TensorFlow extended. So what it does is tries to make this overall end-to-end productionization in part easy. Not easy, I would say. Like, I would say it is proper way of setting things up. Each step of the way is you have a metadata part, you have a proper experimentation tracking. For each experimentation, there is something locked based on version. If something is going wrong with the schema, or you can validate it, then you sort of transform. Like, this is a generic steps. Like, but this is very costly for any initial stage companies to sort of invest in this kind of infrastructure. It will be very costly. So we went on with a different approach. We used Airflow for orchestration, Docker for containerization, and we sort of used Google Run and Cloud Scheduler for scheduling our jobs. What is orchestration? I think most folks would have known, like, you have heard these terms a lot of times, but it's pretty simple, like getting things done. And what does Airflow do? It just executes or orchestrates as DAGs. DAG, directed acyclic. There is no cycle in this. You're just trying to move forward with the pipeline. For example, you see T2 here is a task that waits for T1. Unless T1 is executed and something is expected, you can probably have a sensor tracking whether some output is getting into some file. And then only the T2 gets executed. This is pretty straightforward stuff. For if you have used Airflow, like this, you would definitely know. The good thing with Airflow is it is very flexible. You can easily extend. If you go to the Airflow website, you can easily find the number of things that Airflow supports. It's way, way higher. I can just go to it, but I think, again, I'll just go through it. You see the number of things here, right? These are all the things that are supported by Airflow. So it's very huge. So it's a good thing. So yeah, we sort of moved away from the problematic system which is prone to failures, and failures are, we are not able to track the failures very well. So we sort of moved into this kind of architecture. First thing is we schedule jobs which are related to reading the data. Whatever processing that needs to be done gets done on the Airflow job. The reason why we are using cloud functions instead of just having the data read in the Airflow as well is because cloud scheduler and cloud functions like sort of work very well, and it's not a very complex job to sort of include that in the Airflow in this part. So we separate out the reader and whatever logs that are there, we also go through that. Logs are pretty huge. Like it's 5 times more than what a normal task would be. Task transactions are, you can say, simpler, lower scale, and easily dealt with data than logs. Then you do the pre-processing. Pretty much like any DAG would be a set of tasks which you're trying to implement, and you go forward from one task to another. In the training part, we include the ML flow, and inside the ML flow, we actually log in the commit ID as well. Whichever commit ID we are trying to use for the version of the model, we include that in the ML flow logs. Then we go ahead and register in the Docker. I think pretty much like this sums up like how we have built like the pre-processing, training, and overall workflow. This is how it looks. And the small thing, that the red part you see there, that's the Redis. We sort of pre-compute features during serving so that it's in memory and faster, and latency will be less during the serving time. A lot of folks are like maybe using GitHub-based actions. Like that's pretty much like useful for continuous integration. But the problem with data science teams is their commits are very weird. Like the language of commits is, you try to probably run a Spark notebook and commit that, and there's a lot of hard coding. I know that there is, but I would just say that Docker is better. Like you can just containerize it and ship it everywhere, and it still runs, still works very well. And for tracking, including some of the real-time features, very much like real-time features, like maybe in the last 15 minutes what happened, can be rain-related data. Some area got some sort of climate change. Or it can be that there is a stock quote in one of our stores. This is very much real-time data. But some of the times they get very intermittent. They don't come at all. So we use PubSub. We sort of, PubSub is this message subscription and reading. So there's a publisher and subscriber. We sort of subscribe to some events and publish them. Like, I think pretty much model takes care of pre-computed features, and there is also real-time, some of the real-time features. Then it gets to the model serving interface. So yeah, so what's the difference between, let's say, the previous approach and this approach is, it is much more transparent. It is easier to explain the failures, and that's the false tolerance part. Like, and there is obviously much more scalable. Why it is scalable is because you can always include a new model, include a new feature, experiment it pretty quickly compared to previous architecture. We have no way of tracking whether past experiment worked well compared to what we have done now. So this is much more better way of tracking things. Finally, like we sort of run the training and inference pipeline. Once we add the inference pipeline, we could build a data studio sort of dashboard. This could be shared with your business folks. They understand this very well. It's also a very scientific way of telling that this is how the model is working on the real-time data. I think my talk is pretty short. Not sure. Yeah, I think this is pretty much what I want to share. Like, I think if you have any questions, like, you can just tell. These are the key takeaways. I'm not sure like what is the background of each of you folks. Like, I think a lot of folks are from security, and I see one Kubeflow T-shirt, which is like orchestration again. So you guys have any questions? Like, please ask me. I guess that's all from me.
Okay, can you talk about like what is the model for serving it? Once you have your, once you have the model, the weights. The model is the weights, right? The weights in the Docker image. Do you have the weights in the Docker image itself? And then when you deploy it out, like, do you need some special setup to infer, right? Infer is just deploying those weights in the model and then running queries through it, or like you need some special tricks there as well?
In the Docker setup, we just keep the weights, which is serialized model, and doesn't require anything like extra. Like, it just runs out of the box. If you are talking about like whether or not some sort of pre-processing is required, that part we try to avoid it so that the latency is less. We try to pre-compute during the serving time itself. We try to avoid doing that in the Docker, like, and that is that answering question?
Yeah. So your Docker will have the serialized encoded weights, right? And when you actually deploy this, the inference part, you take that image and then like you have a service which sort of reads those weights, and then you also have inputs from Redis, and then the inference. Like, can you talk a little bit about how inference work? Or do you need special hardware there, or is it like just a normal backend service serving API calls?
You don't need any special service for this. The data that I worked on is pretty small. I think that for 200 mil, you basically running like AutoScale server, it works pretty well. And Redis needs to be managed. The pre-computed weights or pre-computed features that I'm using. If you are going to use like a server in which the Redis runs, that will be very problematic to track. So it should be a managed one. We use Google's Redis server and Redis service, and then it is much more trackable. We use MLflow. If you are talking about versioning inside the code, that is again very different. If model version is there, we try to log the commit as well. into the model training part. So, and also we partition our data, day-to-day training. Let's say today the model is running, we have the folder / whatever date time is there, and we can always go back and check whether why a certain accuracy has increased or decreased. We also do have alerts set. Let's say, I think this is out of your, like what you just asked. Like, yes. We do incremental training. We have very shit version in the beginning, in the first 7 days itself, and try to showcase. So what happens usually is your shitty model tends to be the, you can say, starting point, and like it has generally higher accuracy and only few percentage of accuracy increases after that. Like we sort of observed that, like maybe it's just like limitation of my experience. Like that's what I have seen. Like if you tend to do the experiment faster, it is better for both your company and you. Otherwise, it's just a waste of money. I don't think if you're talking about like including a lot more training, like I think the point of where your company lies in, let's say you already have a weekly transactions of 1 million. You have sufficient data within 1 month, let's say. So you're starting out a project and you already have enough data. If you are increasing like tenfold every week, that's a different use case, but I don't think things work like that. So your question is like, why not include year-long data? So 60 days I have just given as an example, but that's not the real number. But true, we don't consider like a year-long data. That's because there's a lot of pivots inside the startup, so it's better to consider. I treat the holidays in the same way, but I think you question is very valid. Like this is very much related to ML architecture, that you're using, and there's not much related to the talk. But I would say that definitely, like there is a more data means you will probably have, and if it's clean, the data is clean, then sure might result to like a better outcome. But what we have seen is a lot of noise comes in the beginning, and later on it tends to be more impactful. That I mean, more contextually better to use the recent data. We can always give weightage to that as well, lower weightage to the older data. Fair point.
I want to add what he is saying. Say you are forecasting electricity company. What you had demand last winter, that data only yield this year demand. You cannot predict on this year's last 2 months. Or similarly, what he was telling, special limit, like Christmas, like Dasera, this. And in context, I want to ask you another question. How you are relating your forecast with the other forecasted fit that is going to affect you, like weather?
Okay. So two questions, right? Like one is seasonal aspect of it. The seasonal aspect needs to be there, but this, as I told to that question as well, like 60 days is just a number that I want to give for the explanation, not the actual number that were used for the training. It was much, much longer. So the reason why we used like a, let's say, not like a very longer data is Dunzo scaled a lot within like 1 to 2 years. That let's say we had 1,000 or 5,000 odd transactions in the last year. We had like a 1 million transactions within. So it's a lot of scale difference. And the customers kept changing. So, and the geos were new. So we had to use, it is obviously like a great way to improve the model, but that's again not related to, let's say, how to make your experiments better. Or I think there is always a better way of doing things, like building models in the sense. The second question is that like, what is the second one you have?
Other forecasted data that going to affect your demand forecast.
One.
Like there will be rain, so your demand might be increased. So how you are getting those feed and implementing?
We have a rain sensor. We put it in the geos, different places, and that gets accumulated to a database, and that we consume using PubSub. The rain sensor is, I mean, the accuracy of the rain sensor sometimes tend to affect the model as well. So we try to give less weightage. Especially during the rainy season, what happens is your trends sort of almost capture the rains, whatever aspect of it. But again, yeah. Anyone related, like, if you have any questions related to MLOps or any orchestration related questions, like, yeah.
So how often you backtest the model, and how do you use that to improve the model efficiency? For example, if your model is prediction is like X percentage, and when you backtest and see that that is not even close it, and how do you improve that? So how periodically you backtest and validate your model is giving you some appropriate stats?
So when you say backtesting, like oftentimes we build pipelines in such a way that those things are captured. Like if there is a dip in WMAP or AOC, we tend to get an alert, and we can always go back and check based on the date partition, what is the data that is used in the training. And I mean, training happens every day. It's an automated job. And if you're talking about improvements in the architecture, we do it like a periodic fashion of, let's say, 15 to 20 days. We check. But I mean, if there is a huge team, then always someone or other keep working on adding a new feature, changing the model architecture. But the case with Dunzo is like we have just me working on this, so it's longer cycle.
Okay, so on the deployment part, you mentioned that you are, I mean, what you did is our models were deployed in Docker image. Now, these images were these golden images. For example, how do you scale? So, for example, the queries are increasing. So, in line, the cluster number of Dockers goes increasing? Is that your horizontal scaling strategy? Or, and then this is question number one. Question number two, now say you have changed the model. How do you deploy? You build another set of images and do a like a A/B test kind of a thing with a different cluster? And is there a better way at that time? Cost spikes of your infrastructure. How do you manage all those aspects?
I'll come to the second question first, so I don't forget it. So every time we do a cost analysis, when there is a new feature, we sort of understand how much of a cost saving it gives. Let's say we include that feature, how much better the model gets in, and is that necessarily better than the engineering costs that we incur by including that feature? And your question on A/B testing, we do gradually try to move to the new model on X percentage of users, and we do create a separate cluster. We don't do the same. So that's a way to separate things. Like otherwise, it's hard to track which one is like working. I mean, and percentage-wise, like we try to do like first one, like maybe we even have options to give it to 0.01% of percentage of users and see how things are working. And sorry, it's not users. It is a traffic. So overall traffic we take. We don't take the users, and we send like 1% check how the model is performing. We do have test control and see some users don't get the new model. Some get the new model. Some of them don't get both of them. We try to keep the control groups separate from test and see how the new model is performing. And always before we start with including any new feature, there is always a cost calculation. It doesn't go very easily. Yeah. And first question, sir, is that?
First question was deploy inside the Docker or create a new Docker. So that was the
Okay.
first question.
Okay.
The other question was how do you scale? So is it a scalable Docker cluster? That's it.
It is scalable. Yes. Any questions? Sir? Okay, thanks for your time on a Saturday.
He started this just 3 years after he started his career. So at a very young age, he founded this along with his brother and a couple of other friends. And they've been running this for the last 10 years now very successfully. And he's a very active community contributor. And he's one of the first TiDB certified engineer outside the pink app in the world. So without further delay, I think we can go get started. Good luck. It'll work. I'll push it.
Good afternoon, everyone. Today's topic, unleashing data at scale with TiDB. So how many of you heard about TiDB? Okay. So how many of you have worked with MySQL? Okay, I see a lot of hands. So next slide. So this is a small intro about me. Interested in open source technologies. I'm the pink app certified DBA, and I'm also a co-founder of MyDBOps. So I have around a decade of experience with coming back to databases. So this is small about my DBOps, what we have done in the last 5 years of timeline, sorry, 7 years of timeline. So we have around 300 clients across the globe, and we have handled 3,000 plus servers with various use cases and various loads. And we are also a ISO PCI certified company. And recently we got a partnership with TiDB. Okay. So these are the services what we provide in my DBOps. We have a targeted engagement like a consulting, wherein we have a scope, you drive through the project like a migration or things. And we also have a 24/7 managed database support. So these are the technologies what we support. So MySQL, Mongo, Postgres, and recently we added the TiDB and Cassandra, and also we are also exploring other distributed SQLs. So without further delays, let's jump on to the topic. So this is the agenda for today. So what is TiDB? I'll give an introduction about what TiDB is, what does it brings to the table, and what about this history and where it is being used. And I'll discuss about the architecture, how the architecture internally works, and the sharding feature. So TiDB brings in table with a native sharding, how the sharding works and how the data is being split among the nodes, how the fault tolerance is being handled, and the production readiness. So what are the things you should check with respect to the production readiness, and also the major use cases, where it is being used, at what scale they are being used in TiDB. Next slide. So what is TiDB? So TiDB is an open source sharded database which is a drop-in replacement for MySQL, and it is wire compatible with MySQL 5.7. So for example, you have an application which is running with 5.7, you can directly change the connector to TiDB and start work as it is like a MySQL. And it supports both transactional and analytical workload in the same. So this is a kind of HTAB. HTAB is nothing but a hybrid transactional analytical processing system. So let's see, it is also highly available and fault tolerant. So what are the bottlenecks? For example, you have your current system like running with MySQL. The single node bottlenecks comes into the picture. For example, you have a data which is scaling well. For example, till 1 TB MySQL can scale very well. When it goes beyond 1 TB, for example, you have a table which is more than 600 or 700 GB, altering a table might be very difficult, or overnight task activities, right? And also horizontal sharding is not available with respect to MySQL on the fly. That means there is no native sharding. You might need to use Vittis or other third-party solutions to get the sharding done and distribute your data, or else you might need to have an application level sharding. That means the application should be like intelligent enough to or shard aware to get your data. And so coming back to the architecture, so TiDB as a cluster has 3 major components. That is a TiDB cluster, that is a SQL layer. It manages the connection, your authentication, and those things. And next is the TiK, which is your storage layer. This storage layer is based upon RocksDB. We'll explain it in the later slide. And placement driver. This is the orchestrator, or we can call it as the brain of the cluster. Means it handles everything. That means it orchestrates what are the activities that is being done with the TiDB cluster. And the optionally, this is the TiFlash. This makes it as the analytical workload. So the TiFlash is based upon columnar storage. Next slide. So this is the architecture of TiDB. So each works as a decoupled one. For example, this is your application protocol. That means your connector. And TiDB sits and talks with your application. You can this is your SQL layer basically. This SQL layer talks to the storage cluster to 2 APIs, that is a dist SQL API and the KV API. KV API is nothing but a key value pair API. So whatever the queries or the writes which comes through the application is being changed as a key value pair, and this being sent to the storage layer for the writing. And when you give a select or the read query, the distributed SQL, right? So this gets some metadata information from the PD and collects gets the information from the storage layer and travels back to the application. So this is the architecture. We'll discuss in detail about what are the major functionalities of each of the layer. Next slide. So TiDB. So TiDB as a SQL interface, this interface is completely stateless. That means it does not store any of the data. So you can run as much as TiDB nodes you want. For example, you can integrate this along with your application layer so that it can talk to the storage layer directly. And what are the things it does is it handles your connection. So for example, you need to scale up your application with respect to the connections. You can increase the number of TiDB nodes. And parsing and compiling is done at this SQL layer. The first query, the layer of query you send, right? For example, you send a select those queries are being parsed. For example, in MySQL, you have a separate parser which is the optimizer. Here, the parsing and compiling is done at the SQL layer, and the parsed one is sent to the storage layer via the dist SQL module. And from the dist SQL module, it gets the required data and sends it back to the client. And this module also controls the online DDL execution. So DDL operations with respect to TiDB is online. It maintains a separate queue and also a history queue within the TiDB cluster, and it keeps tracks of the jobs to be run within the TiDB for the DDL activities. And garbage collection. So TiDB also supports MVCC, that is multi-version concurrency control, with a snapshot isolation. So when this snapshot isolation is being used, so you have a huge chunk of data being grown at the background. That means your older data, that is snapshot data. So those snapshot data will be cleared by this GC activities, that means garbage collection activities. This is initiated by this SQL layer or the TiDB layer. And also cache table. So this cache table is a new feature in TiDB. That means the maximum size of the cache table is 64 MB. For example, you have a config table that is being not changed. You can have this table as a cache. That means this will be cached in your SQL layer, and whenever you use it, right, it will be available immediately. So the cache table, what kind of data fits into the cache table? For example, a config table or a data that does not change, like a static data you can use for the cache table. And this feature is available from version 6.0. So next comes our transactional storage layer, that is a TiKV. So this is stateful. That means this minimum, the TiKV node should be 3 nodes because to maintain the quorum. And this is persistent with RocksDB. The underlying storage is based upon the RocksDB. It is a LSM tree. It is highly optimized for writes. And also this also supports an distributed storage. That means the data within the TiDB is being segregated or chunked across all the nodes. We'll see in later slide how this chunking and the distribution works with respect to the TiDB. This TiDB, the entire distributed storage and transaction support is based upon the Google Spanner and F1 paper. And this provides a strong consistency. That means TiDB supports ACID compliance. So whatever the atomicity, consistency, every feature is available with the TiDB also. And it also has an inbuilt HA and coprocessor, right? This is a single TiKV node inside a cluster. Minimum, you will be having 3 nodes within the TiDB cluster. Each will have a coprocessor. The functionality of the coprocessor is to reduce the computational overhead as well as the network overhead of the SQL layer. For example, this TiKV will have a chunk of data. That means a partition of data. For instance, when a select star of a table, particular table comes, this TiKV node might have like a range of say 1 to 30 of it, and other node will have the remaining data. So what it does is it gets the data, and coprocessor will run the computing. For example, you do a count of star. The partial count of star is being done here by the coprocessor, and this result is being sent to the SQL layer, that is a TiDB layer, and TiDB collates and add them and send it to the client. So therein, by reducing this computation is being pushed to the TiKV layer, and also it reduces the network overhead of transferring the data from TiKV to the SQL layer. So next slide. So this is how the data is being distributed. Okay. So region. So region is the smallest atomic unit within the cluster. So region maximum size is 96 MB. That means all the data, whatever the data you sent, will be split across each region, and the region will be spread across the multiple nodes. So the maximum region size is 96 MB, and each 96 MB of data act as an peer. That means each will have the regions will be replicated across the nodes. Each region will form a raft group. So so you might have heard of the raft consensus algorithm, right? This is the algorithm behind my MongoDB also. That is the similar architecture. So you can see here. So this is a TiKV, simple TiKV node, wherein you have a region 1 and region 2. Each region will have a start range as well as an end range. Okay. So you can see here. This is just for an example. This becomes one region. These regions are automatically sharded and balanced across the available TiKV nodes. Okay, so each has a leader and a follower. Leader will be responsible for the reads and writes operation, and followers will be for the read operation. For example, if you want to get a read from a follower, you have to give the hint to the SQL layer to get the queries from the follower. So again, followers participate in the election. For example, in case of one fault, as I said, right, it is highly fault tolerant. In case of a node failure, so the next node, that means a follower immediately gets into an election for a voting process, and the new leader will be elected, and it will take over the traffic immediately. Yes, the replicas are already created. Come to the previous slide, I'll say. Sure. So the replica here is a 96 MB region. So region is a replica. For example, next slide. So this is how the replica is being created. For example, region 4, okay, it has the data from P to T, and the same region is being replicated. This is a leader. These are all the replicas. Okay. So it's like a shards. See, yes, replicas are already being replicated to the other nodes. That means this shard of data, this region has a shard of data. That means range of data. Say, come to the previous slide. So here you can see. So this is a region. This is a piece of data. This data is being replicated to the other nodes as replicas. Next slide.
So what are the read consistencies and write consistencies?
So the read quorum.
No, so is it local quorum or global quorum?
It's not local. By default, it's a quorum. So for example,
quorum can be like, say, since it is a distributed, it can have, if I am having my TiDB set up across multiple regions, basically it's a distance lines.
See, so yes. Yeah. So it can be both local quorum as well as a DC, means region based quorum. For that we have a concept called labels. So you call it as in Cassandra you have snitch, right? Similar to that, this TiDB supports a label, wherein in the label you can define what are the nodes to acknowledge the writes. For example, in the other region you might have 3 or 4 nodes. So that the transmission from a val based is higher, right? For example, in the other region you might get on one acknowledgement. That means that entire region gets full. That means it's not a local, it supports both local quorum as well as, by default it's a local quorum.
You mentioned you can give hints via SQL. So is
yes.
the SQL like a superset of what MySQL supports, or do you have additional keywords and such?
So it has additional keywords.
But it supports the entire
MySQL syntax. And see, for example, this forms a single raft group, multiple of which forms a multi-raft design. For example, if this node goes down, so other node will immediately take over with respect to the region, and also your data is highly available. So next.
So segregation of read and write replica is not possible.
Sorry?
Segregation of read replica and write replica.
It's not possible.
Like similar like cockroach.
It's a sharded database. Okay. So coming back to the important point, this is a PD. So PD is nothing but a placement driver. This sits on top of the cluster. This orchestrates everything. This PD will have the global view of the cluster. That means this is the only part of the TiDB that touches both the SQL layer as well as the storage layer. This PD is highly available by default. It has a raft algorithm. For example, it itself communicates within them. For example, if one of the PD node goes down, other will automatically take back. So what are the functionalities of placement driver? The placement driver holds the metadata. So at which node has which region, that means location of the particular region. And also with respect to the distributed computing, the important thing is the timestamp allocation, that means TSO. When an incoming transaction comes through, via the SQL layer, that is the TiDB layer, the TiDB contacts the placement driver and gets a range of TSO for this particular transaction ID plus the TSO, and from the TSO it sends back and gets that. So via TSO and the transaction ID, the isolation is being handled at the TiDB. And other important function of the placement driver is load balancing. So for example, you might have a data region, or for a particular node, it can create a hotspot due to the frequent accessing of the data. For example, you might have a region data that is being held in particular node, that means say node 3 or node 2, that node might be highly under pressure, that means the utilization might be high here. So PD continuously monitors the underlying data, that means the disk utilization, the data utilization, as well as the load of the server. And if a particular node is highly being used, it switches a leader node to that is a leader role to the other node to take over the load balancing. So it's not about a single node. For example, if you deploy a TiDB cluster, right, you should minimally have 3 nodes. Okay, and you can also add n number of node based upon the use case. For the hotspot problem, right, it is solved to an extent. It cannot be solved at all, means at a max it cannot hold. So as you said, if there is a 10% load being handled and 90% load being handled other, it switches, it tries to switches, means it is not immediate. For example, if there is an immediate switchover, right, the leader role switches, obviously the connection and also the queries which is being fired, right, that has to be switched. So it carefully switches the leader role without affecting the production. That means you does not see any implications because of this leader role switch in the application. And also another important thing is, like, for example, as I said, as the region size is 96 MB, beyond which doesn't grow, and also it monitors the regions accordingly. Whenever a region grows beyond 96 MB, that means beyond the allocated size of the region split happens. That means it internally splits the region and distributes it to the other available nodes. And also according to that, it does not split immediately after the 96 MB. It will wait till a range. For example, till 120 MB, it is the highest limit. So post 120 MB, if a region goes, it just splits into 2 regions and distribute among them. And also vice versa, when a region, for example, if you do some deletes and compaction happens, when the region decreases in size, for example, if it goes beyond 20 MB, it will be merged to the nearby region, that is a shorter region, and placed as a single region. Okay, and also it does lot of scheduling by collecting the informations. For example, so when to do this leader split and when to have these scheduling activities is being done by the placement driver. And also the placement driver powers a dashboard. That means a monitoring dashboard is being powered by the placement driver, because this is a place where you get the whole information about the cluster. So again, this is TiFlash. So this is an optional one. So this is an analytical store which is inbuilt with respect to the TiDB. For example, when you have a MySQL, you have to build a separate pipeline to get to the Redshift or via the bin logs. So this is like an automated pipeline. When you enable the TiFlash, it is not like when you just add a TiFlash node, you get all the entire data being populated to the TiFlash. It's not like that. You can control the number of tables as well as the database to be replicated to the TiFlash. So this TiFlash is being asynchronous in nature. That means it gets the data from the TiKV node. They follow a raft learner algorithm to get the data. And also there is a feature called intelligent engine selection feature that is available with the the SQL layer node. For example, you have both, that is a TiKV as well as the TiFlash in the cluster. When a query comes for aggregation, for example, via the SQL layer, the SQL layer passes the query. Is it aggregation? It directly sends to the TiFlash, not to the TiKV node. So this is the intelligent engine selection which is inbuilt with respect to the SQL layer. And also you can give a hint to use a TiFlash. For example, you have a particular query that needs to be go to the TiFlash, not TiKV. You can hint the queries and you can forward it directly to the TiFlash. And this analytical storage is built on top of ClickHouse, so which is an open source columnar storage. So this is in part to that. And this is optimized for aggregation, joins and things. And this is also MPP, that means multiple parallel processing is available. And this TiFlash also has a co-processor. This is also highly available in nature. That means this also has the regions, replicas is available. And also with the TiFlash, you can also define the replication strategy. Means how you intend to replicate it. It's a 2 replica or a 3 replica based upon the node which you create. Okay. So this is a complete detailed architecture. So you have your SQL layer, that is TiDB. So you have your key valued storage layer, that is TiKV. You have the regions forming a wrap group, and also you have the TiFlash. So this is also an, this follows an, as I said, this follows an wrapped learner algorithm to get the data. And this also the DDL means, for example, you do a alter with respect to the TiKV node. This is also being traversed to the TiFlash node, because this TiFlash gets the information of this DDL activity from the PD and applies on its own. Okay, so as I said, it supports a native sharding. So the data which you put into the TiDB is automatically sharded and distributed. So how this sharding works is, so it is based upon a shard key. So shard key is basically a combination of primary key plus table ID. So they call it as a global key with respect to the TiDB. For non-integer means, for example, you have a table with primary key with int. It is directly takes the integer plus the table ID. Table ID is generated. And for a non-int primary key, for example, you have varchar, an invisible int primary key is being generated by the TiDB itself, and it is used for the distribution. So next slide we'll see. So for example, this is a conversion from relational to key value pair. So you have a relational data wherein one means this is a relational, and this is how the table ID is being generated. When, for example, for table T24, row 1, so this becomes a globally identifiable value within the cluster. Next slide. Okay. So this becomes your key, and the remaining becomes your value. And immediately post this, the region split happens. So this is being split across the region 1 and region 2, and distributed across the nodes. Okay. So these are some of the use cases across the world where TiDB is being used. For example, let's take the example of e-commerce platform. Flipkart is being highly using the TiDB. You have super coins, right? For example, you might have shopped and you might have the super coins. This super coin is completely powered by TiDB cluster. And also, Tuya, this is an IoT service wherein they are handling more than 1.5 million TPS per second with a TiDB cluster. And delivery is into the logistics, it is suited for it. And Razorpay is into the fintech and the payment gateway. BookMyShow is also using TiDB. And PayPay is another payment company from Japan. And also you can see a lot of customer stories with respect to the TiDB in this link. Okay, so again, coming back to the production readiness. So as we have seen a lot of use cases, they are all being used in the production. So TiDB is completely production ready. So these are some of the checks you do before the production readiness, or you move towards your workload to the production. And as I said, it is completely wire compatible with 5.7, and also 5.7 is coming to end of life. You can leverage TiDB with respect to that. And this, again, coming back to the UTF-8 MB4 is a default character with respect to TiDB, and some of the collation, for example, you might have in MySQL, you have Latin, Swedish one. Those some collations are not supported. It's only a binary collation is supported. And again, before moving your workload completely, profile your workload in staging or POC environment. Again, CDC with TA binlock means binlock support is available with TiDB. That means you can have a replica from TiDB, you can replicate back to MySQL. And monitoring integration, as I said, the PD as a Grafana dashboard and Prometheus alerting is available. And it also supports, there is a feature backup, that is, they call it as BR. It supports both physical backup with incremental and full backup, and also you can use a logical backup tool such as MyDumper on top of this also. Okay. And when it comes to limitation, the objects, so for example, in MySQL you have the stored procedures, triggers, foreign keys, and those object support is limited with respect to TiDB. Stored procedure is not supported. In the upcoming version, like the current version is 7.1, so from the upcoming version they have plans to support for triggers, but it is not officially released. And the full text spatial index and column level privileges are not supported with respect to TiDB. And there is lot of many other features which is not supported. You just read through the limitation. Those are all not, these are the major limitations with respect to TiDB. Thank you. Sorry? The service discovery works via the PD. For example, when you add a node or when you import the data, that happens via the PD. When you add a new node, that node get attached to the PD, that means discovered via PD, and the PD schedules the balancing. For example, you have added a fifth node, so that fifth node will get the data scheduled by the placement driver. Sorry?
What would be the main
so it has a YAML file and a configuration files.
So that should be on all the 5 nodes?
Yes, not on all the 5 nodes, on the PD. That is a placement driver, the centralized place, right? So that is where your node distribution and scheduling happens.
So will there be one placement driver or each node will have separate placement?
No, see, the placement driver is 3 node.
Okay.
So you can go back to the architecture.
Okay, so there will be 3 placement driver and there will be other, the DB will be other
Separate.
than that. Okay, okay.
It's a decoupled architecture.
Okay, so it will act as a conscious.
Yes,
so
orchestrator.
Okay, okay, okay. So, thanks.
See, the adding a node is online. Means, for example, you can add your nodes and it automatically distributes the data to the node and balance it. It depends upon your data and network throughput and your SIM. Okay.
Here segregation is not there for read and write replica, so we are using cockroach, and cockroach it seems like the architecture which similar to cockroach. Cockroach. So whenever there is a huge read queries, it may be impact your entire application. So is there any solution for that?
So with the read queries, as I said, right, you can use the followers. Means it is not mentioned. It's not by default the leader role. That means it has 2 roles. That is the leader and the follower. So leader tend to take all the by default reads and the write operation. And when you say that you have a lot of read queries, right, you can give a hint to your in the queries to use the followers. That means the followers will be distributed across all the nodes, so by which you can leverage the read scaling.
Okay.
It is highly consistent. That means it has an ACID compliance. So to answer your question, so it basically uses 2 logs, 2 rafts. Okay. So for it writes to the log, okay, and it commits a transaction. From the log, it gets syncs to another raft, that is the TiKV raft, and syncs there. So that is a detailed architecture. I just covered a basic thing.
Like if someone is running a select star or select count star, it will impact in entire nodes, right? If they're big table, so in that case, how it will?
So that's why I gave example. For example, if you run a select count of star, so data is being spread across all the nodes.
Right.
For example, node 1, node 2, node 3. So now the SQL layer, right? So it parses it and it gets the metadata information from the PD. That means where your data actually exists, and it sends a query parallelly to all the available nodes. If you run a select count of star, that is the basic thing. So it sends to all the available nodes. From the nodes, for example, each will have a coprocessor. So the coprocessor will compute the data. For example, it has 1 to 30 data, 30, and it will have 30, 30, 30. So the coprocessor will send data back to the TiDB, and the TiDB is just to collate. That means it add all the 30 and give you the result set back. So if you run anywhere, if you run a count of star, right, it will be spreading across.
Okay. During that time, if some insertion
See, for example,
is going on.
for example, if you have a TiFlash node, so TiFlash is basically for the analytical workload. So if you run a select count of star, so it has a feature called intelligent engine selection. So when you run a select count of star, it understands that this is a aggregation query or analytical query. It directly passes the query to the TiFlash to get you that count of star.
Okay. So means real-time data we will get from
Yeah,
there.
real-time data will get from there. So it is asynchronous. So the analytic count might lag, but not to a greater extent, to a smaller extent.
Okay.
For example, and also one more thing. For example, when there is a live replication ongoing, if this TiFlash node goes down, for example, in certain cases, this does not affect your cluster. So cluster will continue to run, and when it comes back on it gets incremental data. So your analytical performance will get impacted, not your production workload will not get impacted. See, for example, if you are using a mix of workload, for example, mix of both read and analytical workload in the same, so your analytical workload might get impacted, or if with the SQL means the engine selection mode, if it is being used on the TiFlash, right, that might get populated back to the TiKV. In that time, you might see some latencies because of the performance.
So normally SQL data is stored like on files and then you have B3 indexes, right?
So this is based upon LSM3.
Right. So this is the key value
Store.
right? So I think the change in the underlying storage model that would impact the performance of some queries, right? Some queries might be easier to do in the traditional model. Some might be faster and easier to do here, right? Can you give a like a summary of what queries are difficult to do in the KV model versus what becomes easier?
So KV model is basically for your transactional workload. Okay. So for example, it is similar to MySQL. You might have worked with B3, right? Similar to MySQL, the transaction workload will be served but better with respect to the TiKV module, and some of the read performance might get hindered. Actually, this is a known thing with respect to the RocksDB. Okay, so writes are pretty heavy or pretty faster with respect to the, it handles the writes well, and read, when you compare with MySQL, right, there might be little latencies, but the use case and the means the load testing studies does not show that.
I would say it will perform well for an insert-only workload rather than an update-intensive workload, because every update basically creates a child version of the raw, and end of the day it will go through a compaction.
Yes, compaction.
And when compaction hits, your cluster will start starting.
No. So again, this is
like point updation faster. That's the case of LSM.
LSM tree, exactly. And also this RocksDB is being used. You can see Cassandra, Cockroach, everybody. The new SQL uses this, right?
And again, if you want a secondary index, that's also going to support here.
Secondary index is supported, but as you said, there will be a little penalty will be there on the use case.
The penalty will be substantial because you need to create a pivot table for the secondary index internally, which takes it from the storage table.
So that's the main reason. So you do your POC workload analysis, and then you can move safely your workload. So because if you can see the customer data, right, so what we have read from the current use case and those things, we see a positive feedback for the TiDB for the use cases wise. It is again purely based upon the use case. So if I say me, right, for example, most of the customers, if you see the customer use case, so they have moved from Aurora to this node. For example, I said, right, there's a IoT based instance wherein they were using the time series data, the IoT data. They used Aurora, which was not scaling. If you read the use case, right, it is very much elaborate. It's open source. So and also they have their serverless as well as enterprise licensing there, but it's purely open source.
Yeah, I have a question. Can you talk about the secondary indexes? You mentioned, I think I saw on the slide that all the data of a particular tuple, right, it's stored together as the value for a particular key. So is it possible to have an index on, let's say, some field, some column?
Sorry? Yeah, you can have it. It is based upon the primary key. It is built on top of the primary key. So that is your key value pair. So as Harish also said, right, the same thing. Any other questions?